Okay, so hey there folks, my name is Doa, I'm not far from Brussels, and I'm recording this screencast to quickly hook you up with a new custom MoGraph Effector that I put together named the Depolyscize Effector. Now what the Depolyscize Effector does is it rescales MoGraph clones that are being cloned onto a polygonal object depending on the size of the polygons. So as the surface area of each individual polygon is changing over time, it adapts the scale of each MoGraph clone to it, and that's actually all the Depolyscize Effector does. It's a very simple, pretty straightforward idea, but I think it can be very useful for a number of motion graphics purposes, and what's quite shocking actually is the fact that it wasn't possible to do this previously with the standard MoGraph tools, so I'm pretty happy that I've been able to set this up and that I can share this with you now. Now let's take a closer look at how the Depolyscize Effector works and what the controls do. So you can download the effector from the download link that I will post below this video, and you can start playing with it in your own projects. I copy the Depolyscize Effector, I start a new scene, I add a cube to my scene that I will use as a clone. I make it a little smaller, I set smaller, I set smaller, I set smaller. What's going on here? Okay, I add a cloner object to the scene. I make my cube a child of my cloner object. My cloner object defaults to linear mode. We're going to set it to object mode in a second as soon as we have a polygonal object for it to clone onto. So I add a sphere in my scene. I make my sphere editable because the Depolyscize Effector needs access at each individual polygon in order to calculate the surface area. So I go back to my cloner object, I set the mode to object mode, I drag my sphere into the object field of the object tab of the cloner object. The distribution of the object mode defaults to vertices, which we don't want. We want to use the Polygon Center, which positions the clones at the center of each polygon, exactly the center of each polygon, which is what we need. Let's quickly add a material to the scene, give it an orange color, drag the material onto the cloner object, also set the display to Guru shading lines so we see the outlines of our geometry a little better, and we're ready to go. I copied the effector in the previous scene, I pasted it into this new scene. Now if we want to use an effector with a cloner object, we need to drag the effector into the effectors tab of the cloner, so I do that now, and as soon as I let go, you'll see that the Depolyscize Effector is already controlling the scale of each clone. So let's look at what the user data controls do. Well, there are three very simple, very straightforward, self-explanatory controls. As soon as you start dragging them around, you already see what these do. So I'll go over it very quickly. Let's set them to a value of 1 to start out with and show you what that does. It does actually nothing at all. So if each user data value is set to the center, it's as if the effector wasn't there at all. That's that. Now as soon as you start dragging them around, you'll see the effect. The scale factor parameter controls the overall scale of the clones. I'm dragging to the left and the clones get smaller and smaller. I drag it to the right and they get bigger and bigger. So that's one thing. The range control values define the left and the right side of the range in which the clones are being scaled. So the cloner object clones our clones onto the polygons of our polygonal object. The Depolyscize Effector looks at the surface area of each individual clone, and depending on the settings that you set in the range control of the controls, it adapts the scale to these polygons. And and that's actually all there is to the user data controls. Something else about the range control: typically you would use, of course, a minimum value that's lower than the maximum value, but that's not necessary at all. You can also drag the maximum value all the way to the left and the minimum value up, and now the smaller polygons get bigger clones and the bigger polygons get smaller clones. So you can do that as well. Well, that's that. What else can I say? Okay, so the depolysize effector is a custom scripted MoGraph effector that comes standard with Cinema 4D since version 12, which means that we can create our own script, that we can create our own scripted effectors, and which also has the advantage that it's nicely integrated in the MoGraph system. So it has a fall off defaults to infinite, but we can set it to something else, linear for example, and you can see that you can play around with the fall off as well, just like any other effector. It also works with MoGraph Weight. To show you that, I'll add another effector to the scene, a random effector. If we want to see what a random effector does, we need to drag it into the Effectors tab of our Cloner object as well. As soon as I do that, you'll see that the random effector starts randomly positioning the clones. We don't want to use the position, scale, rotation settings. All we're interested in is the weight transform. Now, as soon as I drag the weight transform slider to the right, you'll see that it already starts having an effect on the way the depolysize effector scales our clones. The random effector defaults to a random mode of random, which is a static mode. If we set it to noise, it will make some motion. Okay, so that's nice. What we're doing now is we're using the random weight transform that the random effector is outputting. We're sending it into the depolysize effector, and this random weight controls the way the depolysize effector randomizes the way the depolysize effector is scaling the clones onto our polygonal object depending on the size of the individual polygons. To make sure that this actually works, we need to be certain that the effector that is outputting the weight transform data, the weight data, is being placed before the depolysize effector in the Effectors tab of our cloner. So that's essential. Now that's that. The rest is up to you to discover, to play around with. It's pretty much a standard a standard MoGraph effector. It has a limitation that I will go a little deeper into now, and I will show you a workaround for that limitation. So in order to show you that, I go back to the scene that we were previously working on. Let's quickly drink something. Let's set this up from the beginning. So I delete the plane that we were cloning onto. So now we have a cloner object in object mode that has no object to clone onto. The depolysize effector is already present in the Effectors tab of our cloner object. So all we need is a new object to clone onto. So I add a new plane to my scene. I make it editable. I drag the plane into the object field of the object tab of my cloner object, like this, and already the depolysize the cloner and the depolysize effector start working on it. Now, as you can see, the depolysize effector is, although it's working, it's not doing much at all, and that's of course because each polygon of the plane still has the exact same surface area, so there's nothing too exciting going on yet. So let's add something that will animate the polygons of our plane. In my previous example, I used a sphere with a vibrate tag on it. to give it some motion. Let's quickly do that. And frequency of 0.5 will do. This will move our sphere around like this. Then I added since I'm in version 13 of Cinema 4D, I can use the new collision deformer. I make my collision deformer a child of the plane object. In the colliders tab of the collision deformer, I drag my sphere into it, which, as you can see, already starts pushing the polygons of our plane object down. I'll set the solver to inside instead of intersect, which will push them up. I make my sphere invisible. I drag my sphere all the way down. So that's that. I press play, and you see that our sphere is pushing around the polygons of our plane object. Now, our cloner object was already cloning onto our plane, so I set it to invisible. Let's set it to visible now and see what's happening. What's happening is that the cloner object knows very well how to clone onto an object that is moving, but the depolysize effector is not aware of what's going on. It doesn't know what's happening, and that's a problem. And that problem has to do with, let's make my cloner invisible for now. If I click, so I'm in point mode now, I click I click onto my collision deformer, and you see that the deformation is visible. I click on the plane, and the plane is still flat. And the depolysize effector looks at the plane to calculate the surface areas of each polygon, and is not aware of the fact that the plane is being deformed. So we need to do something about that, and luckily there is a workaround that we can use, and that workaround involves the correction deformer. So I add the correction deformer to the scene. I make the correction deformer a child of the plane as well. Now the correction deformer always looks at everything that's happening with the object that it's a child of. So it looks at the plane. Let's make the collision deformer. Let's disable it for a second. The plane is a flat object. The correction deformer looks at the plane, and I make the plane invisible and the correction deformer visible. It looks at the plane, and it takes the shape of the plane. Now the correction deformer is not aware of what the collision deformer is doing to our plane yet, so I need to drag the correction deformer below the collision deformer, and now the correction deformer is aware of what the collision deformer is doing. So the correction deformer always looks at what's happening before it, and then reflects that action into its points. To make this visual again, I set my plane to invisible for a second, and I set the correction deformer to visible, and as you can see, the correction deformer is moving along nicely. Now maybe you think now that the correction deformer is the solution. We can drag the correction deformer into the object field of the object tab of our cloner object, but this won't work either, because the correction deformer is not a polygonal object, and the depolysize effector needs an object with actual polygons to work with. So I drag my plane back into the object field, and in order to translate what the correction deformer knows now, the point data of our moving plane, we need to add a little espresso. And we're going to do that now. So let's make the cloner invisible again. Let's call our plane master. We're going to use this plane as a master to drive another plane that we call plane slave. So we're going to pass on the information that the correction deformer has about the points of our moving master plane, and we're going to pass these points into the points of our slave plane. So our slave plane is a simple object without any children, just a little espresso that is moving in the exact same way as the plane master is moving, and then we'll clone onto the slave plane, and then the depolysize effector will be aware of the changing polygons. Sounds a bit complicated, but you'll see soon enough how this works. I go to my slave plane, I add an espresso tag to this, I open my espresso window, and we're going to work with the correction deformer. We're going to pass information, point data from the correction deformer into the points of our plane slave object. So we need another point node for the plane slave object. So this point node will look at all the points of our plane slave object. This point node will look at all the points of our correction deformer. Now we need the position of each point. We need to pass the position of each point of the correction deformer into the position of each point of our plane slave object, like this. Now we need to loop through each point of our correction deformer and pass that data onto each point of our plane slave node, because standard without looping through these points, these points also only look at the first point, the point with index number 0. So we need to come up with a loop. There is an object, a node named iteration node, that allows you to loop through a number of elements. I add another point node to the espresso window, because the point node also allows us access to the point count. So I connect the object port of the correction deformer to the object port of the new point node. I pass the point count of the correction deformer, so the number of points that our correction deformer exists of. I pass that into the iteration endport of the iteration node. So the iteration node starts iterating at index number 0, at point 0, then point 1, then point 2, then point 3, and so on until it reaches the last point, like this. Now that's that. Now we need to connect the output port of the iteration output of our iteration node to the point index port of our first point node. So now the iteration node already loops through all the individual points of our correction deformer. Now we also needed to loop through all the individual points of our plane slave object. So we connect the iteration output port of the iteration node to the point index port of our point node as well. And the setup is ready. You see, it takes some time to set up, but this is some simple espresso that you can save as a preset and use over and over again in your projects. And for now, because I'm not smart enough to build a smarter depolysize effector, I invite you, if you're smarter than me, to take a look at the script inside of the depolysize effector, and make it better, add functionality, optimize the code, get some bugs out, whatever you can do with this. Make me a happy camper, make this better. Maybe I can learn something from you, but I'm not smart enough just yet to build a depolysize effector that is aware of that can work with a polygonal object that is being deformed by a number of objects. So this is the smartest solution I've been able to come up with. So you need a correction deformer and a little espresso to make. So I make my, and now we're back at where we were. I make my master plane invisible, and as you can see, the plane slave is moving just exactly the way our master plane was moving, but it has no children, it has no deformers on it. It's taking all that information from the master plane. So the correction deformer is doing its job, and it's passing on the data perfectly. Now I make the cloner visible again. The cloner is still set to clone onto the master plane. Now we drag the slave plane into the object field of the object tab of the cloner object, and as soon as I let go, you'll see that this works. So now the depolysize effector, all it knows is that it's looking at a polygonal object with a changing polygon size, with polygons that are changing in size, and it just does the calculation, and it does its job, and it's not aware of anything else that's going on. So that's that. A little workaround, correction deformer, an espresso node, and that's all. Well, I think it's time to wrap up. I think I explained everything I wanted to tell you. Yeah, I'll leave it at that. As I already said, this is the first time that I make an effector. I had to come up with a number of homemade solutions for a number of problems I ran into while I was building this thing. So if you're smarter than me and you can make this a little better, I would love to see it. I would love to see this grow into something that's actually better than what I've been able to come up with. I love to learn from you, so surprise me. Then the last remark before clicking the stop button on my screencast software. Some credits. Although I built the I made the script in the depolysize effector myself. I took the surface calculation code. I found it somewhere on some old board, and there's two guys, one guy from the States, Nick Woolrich, and one guy from Slovenia, Sandy Dolchak. We're already talking about calculating surface areas long before the custom MoGraph effectors existed, and I found a conversation between these guys in 2005 or something, where they were already talking about this, and I used their code. I adapted a little bit to this effector, but credits to Sandy Dolchak and Nick Woolrich for doing a lot of smart mathematics. That's one, and the last credit goes to Sataniev. He's a guy from Ukraine, who actually just a couple days ago posted a video clip on Vimeo in which he attempts to do the exact same thing as what we've been talking about for the last 20 minutes, resizing objects depending on the size of individual polygons, and he uses a very interesting but very elaborate espresso setup that required him to that forced him actually to make his cloner object editable, which made him lose all the MoGraph functionality. And it's actually watching his presentation a couple days ago that I started thinking about, this should be possible with MoGraph. Now that we can make custom effectors, I should be able to come up with a way to calculate these surface areas somehow. So I started looking around for formulas and ways and techniques on how to set up a custom effector, and actually, rather to my surprise than to my expectation, it worked out. It only took just a couple of hours, and the effector already worked. So credits to these three guys. I'll post a link to the effector below this video, and I hope you have a lot of fun with it. If you like it, just or if you use it for something interesting in an interesting project, or you do something cool with it, or you start scripting and you add some interesting functionality to this, or this inspires you to build your own effector or whatever, would be nice if you would let me know. It's always a great feeling to see or to notice that the things that you do have some effect in the real world. That's all. I wish you a happy life. You